Have you ever struggled with adjusting a 3-point fully mounted plow? Follow along in this video as we adjust this plow from start to finish. We'll show you the physics of the moldboard plow, and we'll also show you incorrect adjustments and how to correct them. So let me introduce you to my lovely wife Courtney, who's going to help. So let's head to the field. It's a beautiful fall day here in southeast South Dakota to plow under oat stubble. We are using a 1962 Minneapolis Moline M5, and we're pulling a 4-bottom, 14-inch frame Minneapolis Moline 5000 series 3-point mounted, fully mounted plow. So let's start off with an example of a well-adjusted moldboard plow. Each plow bottom is plowing the same width and the same depth. And you can see that by watching the plow from the rear, and you can see each plow bottom throwing equal amounts of dirt. The plowed ground is level. No furrow sticks out as being high or low or wide or narrow. Each coulter is adjusted properly, and you can see that in the clean furrow wall. You can also see that in how each plow bottom smoothly turns over the furrow slice. When the coulter's in the wrong spot, it forces the plow bottom to rip and tear at the furrow slice. Soil has to boil over to the next bottom. That furrow slice just does not cleanly get turned by the plow bottom when coulters are out of position. The plow frame is level front to back and side to side. Why is that important? Because it puts the plow bottom in the proper orientation for it to turn over the soil as the designers intended it to. When your plowshare is shot and the plow won't go in the ground, so you're forced to shorten the top link to get the plow in the ground, you're rolling the plow forward and you're raising the tail of the moldboards up, and you're not giving that plow bottom its best chance to turn over the furrow slice properly. We are plowing at a reasonable depth between 6 and 8 inches deep. Any shallower or deeper than that reduces crop yields for the next year. Too deep for a given plow bottom chokes up the plow bottom and doesn't turn over the furrow slice and doesn't cover residue as well as it could. And finally, the line of draft is in the right spot between the plow and the tractor. The front bottom is cutting the correct width at the same time as the tractor is a pleasure to operate. The plow is not pulling the front of the tractor to the left or to the right. The steering is neutral. The operator is not fighting the steering wheel. So let's dig into adjusting this plow, and we'll start with the very first thing to do, and that's figure out tractor wheel spacing. If you needed a reason to get an operator's manual for your plow, looking up the wheel spacing for the tractor would save yourself a lot of hassle. Because this plow does not allow you to slide the cross shaft, only turn the cross shaft, you have a very narrow range of wheel spacing that will make things work correctly. Because the tractor wheel spacing plus your cross shaft adjustment gives you the right front furrow width and the correct line of draft. If you don't have your operator's manual, we can do some reverse engineering, do some measuring, and see if we can figure out what the wheel spacing should be. So the first thing we'll do is measure from the center of the top link, or the mast of the plow, over to the landside of the front bottom. And it looks like it measures about 7 inches. So 7 inches plus 14 inches, because that's our frame width, puts us at 21 inches from the furrow wall to the center of the top link. 21 inches times 2 equals 42 inches. This does not mean we should have 42 inches between the tractor tires. When the tractor leans in the furrow, it actually translates to the right. And we need to figure out how much it translates, because that's going to affect our wheel spacing. So what we need to solve for is the distance X along the axle center line. How do we do that? Well, we'll start with what we know. We know that the rolling radius of a 15.5 by 38 tractor tire is 31 inches. And we know that our plowing depth is about 8 inches. However, we have too many unknown variables here to solve for X. So I'll have to assume a center-to-center tire distance of 60 inches, and then we'll iteratively solve for X here. So we'll have to dig back into our memory hole back to 10th grade trigonometry, and we'll have to remember our right angle triangle definitions. And in this case, we'll use the sine function. So sine theta equals the opposite leg length over the hypotenuse leg length. So sine theta equals 8 over 60. And we'll solve for theta in this case, and we come up with theta equals 7.66 degrees. So now we can hop over to the other triangle. Both thetas are equal to each other in this case, and we'll use the tan function. So tan theta equals opposite over adjacent. So tan of 7.66 degrees equals x over 31. We'll solve for x, and we come up with 4.2 inches. So 4.2 inches plus the 7 inches that we measured on the plow plus the 14-inch frame width gets us to 25.2 inches. 25.2 times 2 equals 50.4 inches between the tractor tires. And we add in the width of the tractor tire, and we get 65.9 inches center to center on the tractor tires. We guessed 60 inches initially. So now let's recalculate everything really quickly again using 65.9 inches. So we'll use the sine function and solve for theta, and we come up with 6.97 degrees. Then we'll use the tan function again and solve for x, and we come up with x equals 3.8 inches. So x did not change much. We came up with 4.2 inches on the first round of calculations. So I'm going to roll with it. So 3.8 inches plus the 7 inches that we measured on the plow plus the 14-inch frame width puts us at 24.8 inches from the inside of the tractor tire to the center of the tractor, which is pretty gall darn close to what the manual suggests of 25.5 inches from the inside of the tractor tire to the center of the tractor. So I would be really, really curious if you've got a manual for your plow, go out and do these same measurements and same calculations and see what you come up with. And here's why wheel spacing is so important. Not only does it give us the correct front furrow width, it also gives us a good line of draft. If we draw the line of draft from the point of resistance on the plow to the instant center of the lower links, we want that line of draft to come as close as possible to passing through the dynamic center of gravity of the tractor. And what that does for us is the force of the plow does not create a moment or torque about the dynamic center of gravity of the tractor trying to turn the tractor. And what that looks like is the front of the tractor being pulled one way or the other. So here's what it looks like when the line of draft is good. We can see the front of the tractor is not being pulled one direction or another. It's a pleasure to operate, and the operator is not fighting the steering wheel. And this is what happens when we try to hook the plow to a tractor that is too wide. We have to force the plow to the right to get the front furrow width to be correct, which shifts the instant center of the lower links to the left. So now that line of draft, that plow force, is going to try to rotate the tractor counterclockwise. And this is what that will look like. It is always trying to pull the front of the tractor to the left towards the unplowed ground. The front wheels are always trying to climb out of the furrow, and it's just not fun. And this is what it looks like with wheel spacing that is too narrow. The cross shaft of the plow is rotated to steer the plow to the left, which shifts the instant center of the lower links to the right, which also shifts the line of draft to the right, which creates a clockwise moment or torque about the dynamic center of gravity of the tractor, which pulls the front of the tractor to the right towards the plowed ground. So enough of this, let's get out to the field and do some plowing. And we'll start off with a common problem I see with 3-point fully mounted plows. Usually what happens is the plowshares are dull, they've lost their suck, and the only way the plowman can get the plow on the ground is to roll the plow over, meaning he shortens the top link and short right side lift arm to make the plow run on its points, and that's the only way he can get the plow to go in the ground. and this might be hard to see from the seat of the tractor. So I would suggest drag your wife out to the field, grab a friend, or find a trustworthy looking bystander at a plow day and ask them to drive your tractor for you so you can watch the plow from the ground. And then it will become really obvious to you. You'll see that the plow frame is leaning down in the front. If you look from the side, you'll see the plow frame is rolled over to the left if you're looking from the rear of the plow. And this is really a condition to avoid. And problems really start to compound for the plowmen. First off, the soil is not hitting the moldboard where the designers intended, so it's not turning the soil over like it's supposed to. The plow's rolled over, so the tails of the moldboards are pulled up, so the soil is not getting turned over. You'll see soil that doesn't get turned over completely, furrow slices that fall back into the furrow bottom. The second problem that this creates, you'll notice that the tail wheel is way up in the air and it's not rolling, which also means that landsides are not down in the furrow bottom where they're supposed to be to hold the plow. So the plow will start kicking over to the left, it'll start cutting wider, it won't plow a consistent width, and that wouldn't happen if the plow was rolled over in its proper position. The third problem that this creates, and you've probably seen this at a plow day, when a guy has his plow rolled over on its points, he's also always playing with his depth lever. The plow just does not plow a consistent depth. And the reason for this is because the plowshares are dull, there's no suck, there's a sled runner behind the point. So the plowman has rolled the plow over, and that means he's rolled the plowshare up. So he's trying to get rid of that sled runner. The problem is that sled runner is still there, and he's only found the balance between the plow going in the ground and that sled runner still supporting the plow. And the problem is that's not the correct way to control depth. And what will happen is the ground will get hard and it will drive the plow out of the ground from that sled runner. Then the ground will get soft and then the plow will sink into China, and he's always playing with the depth control lever. So this is probably a good time to talk about depth control methods. We'll start with the most basic depth control method. It's called free link operation, which means the tractor depth control or draft control is not being used. The links are free to operate. And so the depth is 100% controlled by the plow itself. You notice the top link and the bottom links are not parallel to each other. If you draw a line through those links, you'll get a virtual instant center notated by the F sub V. So the plow rotates about this virtual instant center. The next thing we need to do is draw a line from the point of the share to where the tail wheel runs along the ground, and you'll notice that in this red arrow. And so what will happen is the plow will rotate about this virtual instant center and keep going down until that red arrow is in line and parallel with the direction of travel. And so you can see how if you shorten the top link, the plow will go deeper. And if you lengthen the top link, the plow will shallow up. One thing to keep in mind here is the plow must be designed to allow for this operation, meaning the tail wheel must be large enough and wide enough to be able to support the plow. Or if you don't have a tail wheel, you need to have a large enough heel pad on the land side to be able to support the plow. When I think about like a little Ford Dearborn or Ford Ferguson plow, the real skinny rolling land side almost, and tail wheel, that's not going to support the plow. Or a Kverneland match plow that has a land side but no heel to support the plow. That's not going to work here. And before I get too carried away here, I should explain what's going on in this diagram. So the soil in this plane, the soil force acting on the plow is represented by the arrow or the vector labeled R sub V. The weight of the plow is represented by the W vector. We add those two vectors together to get the AB vector. You can slide that vector down as long as you keep it in the right location, but just sliding it up or down, that's fine. So we slide it down to where it meets the tail wheel, so we can do some vector math to figure out how much force the tail wheel supports, and whatever's left over gets pulled up by the tractor, and we draw that line forward to the instant center of the upper and lower links F sub V. And so the force that the tractor is pulling up on the plow is labeled by the P sub V vector. Just keep in mind the location and especially the height along the rear axle of this P sub V vector line of action as we go along here. The last thing I'll mention here about this depth control method, a common complaint I hear about 3-point mounted plows is that they don't plow a consistent depth. They don't follow the lay of the land well. Well, you can picture here, since this red arrow represents the direction of travel of the plow, you can picture how if the plow and tractor were going over a hill, the plow would go deeper. And you could also picture that as the plow and tractor is going through a swale or a concave contour of land, the plow would shallow up. And the way to mitigate that is to add a gauge wheel that runs on top of the land to control the depth of the plow, which brings us to the next depth control method, which is free link operation with a gauge wheel. This is the absolute best method for maintaining a consistent depth. When you have a gauge wheel on top of the land, you know how deep the plow is going to go. This method is used by contest or match plowing guys when they're plowing with their Kverneland and Ransom's match plows. One downside of this is, and I've experienced this, is when you've got a single gauge wheel and even if the ground's really dry and hard and rough, the plow can actually bounce up and down over that rough ground. So that's why, if when allowed, match guys will add an additional gauge wheel so you can smooth out the ride of the plow. If you don't have an additional gauge wheel, but if your plow is an old vintage plow that still has a tail wheel, you can adjust your tail wheel and get gauge wheel and your top link to try to get the tail wheel and gauge wheel to share in the load of supporting the plow. And that's probably the best way to go if you've got that kind of plow. Now, however, do not use this gauge wheel depth control method as a crutch to deal with your dull plowshares. Remember how I was just talking about the sled runner on a dull plowshare will drive the plow out of the ground and cause poor depth control because the sled runner will drive the plow out of the ground in hard ground, and then soft ground will allow the plow to suck into the ground, and your depth is just never going to be consistent. So I've seen where guys are dealing with that, so they've shortened their top link so they can get the plow on the ground, and they experience poor depth control. So then they rig up a gauge wheel on their plow. Yes, it fixed the inconsistent depth control problem, but now your plow is running on its points, the tail of the moldboards are pulled up, and the plow is not turning the soil over the way it's supposed to. And so, orientate the plow the way you want it to run. And then hopefully with the help of this video and with experience, you'll be able to notice, hey, I think dull plowshares are controlling the depth of my plow more than the gauge wheel, and then you can fix that problem. One last thing to mention on this depth control method. Most match or contest plows will not have a tail wheel or a heel on the land side. So any adjustment you make to the plow, whether it's the lift arm or the top link or the cross shaft, the plow basically rotates about that depth wheel. And so match plow guys will use that to their advantage and will actually lengthen the top link and roll the frame of the plow back so that they'll use those long tails of those moldboards to pack the furrow slice down. It essentially gives you a much greater degree of freedom to adjust that plow the way you want. Okay, so pay attention to the P sub V vector and its line of action or line of pull on the tractor as we transition to the next depth control method, which is restricted link operation. This is where the magic of Harry Ferguson's invention comes to play. Restricted link operation means we are using the draft control of the tractor. Notice how much higher and steeper the line of pull is in this situation. When the draft control of the tractor is being used, the tractor and plow essentially become one. So now your P sub V vector, the addition of the weight vector and the soil force vector, essentially becomes the force that is acting on the tractor. That's how you get the magical force transfer to the tractor. This is how you get a small and light tractor to pull more plow than you think it should be able to. You'll also notice in this theoretical diagram that there is no vertical support on the plow. No landside, no tail wheel, and no dull plowshares that are supporting the plow. That's how you get all the soil force and all the weight of the plow transferred to the tractor for traction. So anyway, hopefully you can see by studying this diagram how a guy could adjust his top link too short and not realize it, since the plow is 100% being carried by the tractor. So with all that being said, here is how I would adjust a fully mounted 3-point plow, if the design of the plow allows it. I would start out by adjusting it as free link operation using just the tail wheel. Adjust your top link, adjust your lift link, your cross shaft. Then you know the plow is fundamentally adjusted correctly. Then add your gauge wheel if you're going to use a gauge wheel. And the gauge wheel and the tail wheel can both share in supporting the plow. And then you can inch up on your draft control lever so the tractor is pulling up on the plow a little bit to get that weight transfer to the tractor for traction. You can use all three methods like I'm doing. That way you get the best of all worlds. You get good depth control and you're getting some weight transfer to the tractor for traction. If you only want to use the draft control of the tractor for depth control, you can still start out adjusting it for free link operation, then inch up on the draft control lever, and you could shorten the top link up just a hair so you know that tail wheel is not supporting the plow, and that way you're getting maximum weight transfer to the tractor. So with this plow, I tried to start out with free link operation but was unsuccessful, because when you're in free link operation, the top link is in compression, and between the slop in the top link and the movement in the draft sensing cylinder on the top link, it moved too much. So then when you lift the plow up, the top link goes into tension. And once I got the top link long enough to control the depth in compression, it was too long to be able to lift the plow and get it off the ground when I lifted the plow up. So I had to lift the plow up just a hair using the draft control just to get the top link into tension just enough, and then I could go about doing my adjusting. The thing with a 3-point mounted plow is every adjustment affects every other adjustment. It's hard to give you a step-by-step procedure. Follow this procedure and your plow will be adjusted correctly when you're done. It's almost an iterative process, and once you adjust one thing, you'll have to fine-tune all the other adjustments. So anyways, let's do some actual adjusting. We were talking about the plow running on its nose as depicted here. The first thing we have to do is fix the root cause, the reason why we're forced to run the plow on its points, and that is dull plowshares. So let's replace or fix on these plowshares to sharpen them up. You can find more information on that in my plowshare video. And then we can adjust on the plow. So let's fix that. We need to lengthen the top link and lengthen the right side lift arm together to roll the plow frame back. And you'll notice the plow is level across the bottoms. Each plow bottom is turning equal amounts of soil. So we need to roll the plow back, and that's why we have to adjust the top link and the right side lift link together. So we're going to lengthen the top link. And then we're going to lengthen the right side lift arm. Oh, but now we've gone too far. We've rolled the plow too far back. You can see the plow is lower in the rear. You can see the plow standards are not straight up and down. They're leaning towards the plowed ground. You'll also see the furrow bottom is shiny because the plowshare is polishing the furrow bottom. We've rolled the plow back so far that we're driving the plow out of the ground with the tail wheel. So let's fix that and roll the plow back the other way. So we're going to shorten the top link, and then we're going to shorten the right side lift arm. Hey, there you go, that looks better. The plow is running deeper, the standards are straight up and down, the plow frame is level left to right, and the plow frame is level front to back. So now that we have the plow halfway running level, we can move on to other things. And the next thing we notice is the plow is clearly not running straight. If you eyeball down the furrow wall and look at the beams are clearly not parallel with the furrow wall. So we're going to fix that by fixing on the land sides. Don't be tempted to lock the plow in with any kind of sway limiters or try to force the plow over with those sway limiters, and here's why. Let's look at the forces on the plow in the horizontal plane. If you add up all the soil forces acting on the moldboards and the shares of all four plow bottoms, that can be represented by one representative vector, and we'll label that the soil force vector here in this diagram. Where that soil force vector intersects the cumulative forces of the land sides, that's where the point of resistance occurs on the plow. We can draw a line from that point of resistance to the instance center of the lower links, and that creates the line of draft. So at the confluence of these three vectors, we'll do some vector math. We'll subtract the pull force from the soil force. Anything left over is forces that the land sides have to absorb. Point number one here is, even when the plow is adjusted perfectly, there's always going to be forces on the land sides pushing the plow over to the unplowed ground. And point number two here is, you never want to lock the plow in solid using sway blocks, sway limiter chains, sway links. You want the plow to have the freedom to move horizontally because you want to be able to steer the tractor. When you force the plow over one direction or you lock the plow in using sway limiters, here's what happens. When you lock the plow tight, the plow and the tractor essentially become one, which is bad news, because now you've got that soil force acting on a big old lever arm about the dynamic center of gravity of the tractor, and that soil force is going to try to rotate the tractor clockwise and always pull the front of the tractor towards the plowed ground. And that's no fun plowing like that. So here's why the plow is not pulling straight. These land sides are severely worn. And when they wear, they round off like this, which makes a really nice ramp for the plow to work up and over on. So that's far from ideal. And you can also see we put new shins and shares on this plow. And so you can sight down the top edge of the land side that's not worn so bad. And you can see there's quite a bit up there that's getting cut that's not getting supported by the land side. So we need to fix that. And we're going to fix these land sides by just welding on the old wore out plowshares that we took off the plow. Be quick and dirty, cheaper than buying new land sides, and probably work as good, or if not much better than new land sides. All right, we'll give this a try. Got all the land sides welded up. I cut the first three at an angle to make them look pretty to match the profile of the existing land side. I left the back one a little longer and mounted it a little further back just to make the rear land side longer, because that's what you want to do to leave the rear land side longer and support the plow a little better. So we'll go check it out and see how it works. Well, it looks like we've got that fixed. The plow is now pulling straight. When we sight down the beam and the furrow wall, they are parallel to each other. So let's move on to adjusting Coulters. Let's start off with a common fault I see with adjusting rolling Coulters, and that is the Coulter running on top of the share, meaning it's too far to the right. And when your Coulter is adjusted like this, the Coulter is really not doing you any favors. When it's too far to the right, you're making the share and the shin of the bottom rip and tear at the furrow slice. And you should be able to see this from the seat of the tractor. The plow is just not going to cover residue very well. You're going to see the furrow slice being ripped by the moldboard rather than being cut cleanly by the coulter. You'll see dirt boiling over, boiling to the left, to the bottom behind the bottom you're currently looking at. And you're also going to see the furrow wall crumbling rather than having a nice clean furrow wall. So let's stop and fix this. We're going to turn the coulter out towards the unplowed ground to the left if you're looking from the rear of the plow. And when you do this, don't forget to adjust the clamp that locates the coulter fork on the shank. That's caught me many times before, where you'll adjust the coulter and then the coulter's not going to run where it's supposed to because that clamp is holding the coulter over. So now let's plow maybe 20 feet and stop and check things out. And what we're after is a little bit of a step in the furrow wall. That step tells you the coulter blade is running just a hair outside the share. And that step also gives you a little margin of error. If the coulter blade would ever run just a little bit to the right, you've still got some margin there before the furrow wall starts to crumble in. How deep should a coulter run? Well, only as deep as necessary to cut the residue. Any deeper than necessary just unnecessarily rides the plow out of the ground. I usually end up about half the plowing depth, so about 3 to 4 inches deep. And you can verify that by measuring down from the ground down to your little step in the furrow wall. So now that the rear coulter is adjusted in and creating a clean furrow wall, let's adjust the other 3 coulters to match. And we'll start by measuring the rear coulter blade over to the frog so that we're quantifying how far that coulter is adjusted off the bottom. And then we'll adjust the other 3 coulters to match. So now that we think we have all 4 coulters adjusted properly, let's plow a little ways and stop and check our work. So we'll stop and get out and measure from coulter blade to the furrow wall of the bottom in front of it and check to see what each bottom is cutting. And that does 2 things for us. It double checks our coulter adjustments so we can tweak the coulters and make sure each bottom is cutting the exact same width as the others. And number 2, it tells you what the plow is actually cutting. This plow frame is 14 inches. Ideally, it would cut 14 inches. But if we didn't fix the landsides correctly, maybe we haven't fixed the landsides yet, or maybe the soil conditions are different from the last time you used the plow. So maybe today the plow has decided to cut 14.5 inches. Maybe it's decided to cut 13.5 inches today. We need to know that width so that we can adjust the front furrow width to match the other bottoms. So if we tweaked any coulters, let's plow 20 feet and stop. And now let's check our front furrow width. Our other 3 bottoms are cutting exactly 14 inches, so we're looking for 14 inches. But it looks like our front bottom is only cutting 13 inches. So let's fix that. So let's turn the cross shaft a notch or 2 to widen out the front furrow. Let's plow a little ways and check the front furrow width again. Looks like we've got it this time. The front furrow width is 14 inches to match the other bottoms. With all 4 rolling coulters adjusted, things are looking pretty good. Definitely check out my How to Adjust Rolling Coulters video where I pontificate more on how to adjust rolling coulters. Now that we're getting close to getting this plow adjusted in, let's stop and check our depth using a tape measure, something most YouTube plowmen seem to forget at home when they are speculating on the depth that they're plowing. Looks like we're going a solid 8 or 9 inches deep. And since we turned our cross shaft, we better take a critical look at our right side lift arm adjustment. Because not only does the cross shaft steer the plow, it can also raise and lower the front of the plow. And it's really just a matter of studying the furrows that we're turning to make sure they're still matching. So in this case, I think we can do a little bit better. Let's shorten the right side lift arm and see what happens. And it looks like we've shortened the lift arm too much. The soil coming off the front bottom is clearly not filling in against the previous pass. And when we study the soil coming off all the moldboards from the rear of the plow, we can clearly see there's less soil coming off the front bottoms. So let's lengthen the right side lift arm to fix this. And we've gone too far again. Now the lift arm is too long. The front bottom is piling up the soil. The soil turned by the front bottom is too high. And when we look from the rear of the plow, we can see more soil coming off the front moldboards. So let's shorten the lift arm again. All right, that looks pretty good. I think we've got it this time. All 4 furrows are matching, and what we're plowing is filling in and fitting in with the previous pass. But let's recheck the front furrow width, because when we monkey with the lift arm, that also changes the width of the front furrow. So let's stop and recheck our front furrow width. And good, we're still at 14 inches. All right, I think we finally got it. Remember when I said adjusting a 3-point mounted plow was an iterative process? There's lots of things to work through. Top link and sidearm and cross shaft and Coulters, and then when you adjust one thing, you gotta adjust them all again. I'm satisfied with the work that the plow is doing. All 4 furrows are matching. The plow frame is level front to back and side to side, and we're covering residue pretty well. To make this video possible, I'd like to extend a special thanks to Cousin Philip for the use of the tractor and plow and for the ground to plow. I would like to thank my lovely wife for driving duties and doing an awesome job being a camera woman. I would like to thank Sean Karsten for his help with video editing. And I would like to thank David Sturzenbecker for his microphone voiceover help. That's it for this video. I hope it helped someone. Thanks for watching, and stay tuned for the next one.